All right, we're working on one-step equations. So let's take a look at that. And with one-step equations, you need to write it out. And you're going to use inverse operations. The inverse operations undo each other. Now, I know you're tempted to do it in your head, but we're setting up those foundational baby steps to solving larger equations. So let's see what this looks like in all four operations, okay? So, and again, you will probably be able to do this mental math, but I want you to see the process of writing it down. So if I have a plus 5 equals 15, you already know that a is going to be 10. But with inverse operations, you're going to look at that number that's hanging around with the letter A, the variable, and that's the number you're going to get rid of. You're going to peel it off or undo it or move it to the other side. And sometimes it helps to draw a little line down from that equal sign and have it kind of like be a wall, and you're going to push that other number over the wall. So looking at that a plus 5, it's adding, so we need to subtract. And whatever we do to one side of the wall, we're going to do to the other. We're going to subtract 5, because whatever is hanging out with that letter, that variable, that's what we're going to write and rewrite. When that happens, that a will drop all the way down, and this right here, you see that? That becomes that identity number 0. So we don't need it anymore. So a is now by himself, and when 15 and negative 5 combine, you're going to get 10. A equals 10. So let's look at it from a subtraction perspective. If I have b minus 8 equals 30, well, I want to get that 8 pushed over that wall, so we're going to write the 8 on both sides. But I need to have the opposite sign. So that's a negative or a subtraction sign on either plus. And in order to do that, I can't change the value. That's why everything has to be the same on both sides. That positive 8 showed up in both places. These zeroed out, so they're gone. B drops down, and 30 and positive 8, positive 30, positive 8 will give me 38. No big deal. These ones are really simple, and they're going to be simple like that for a while. Let's look at when we have multiplying and dividing ones, okay? So again, you're going to know these mental math. 3x equals 15. What this is asking you is that what times 3 will be 15? Well, you already know that it's 5, but we're going to show it in our solving equations method. These two are multiplying. They're stuck together, they're multiplying. So we're going to do the opposite of multiplication, which is division. And we're going to show division with a fraction bar. And we are going to divide off whatever number is hanging out with that variable. So you can see I've done the same thing to both sides. What happens here? It's really kind of interesting. This 3 over 3, if you look at it, it's that identity number 1. You see it? So now I've got x dropping down by himself. I forgot to put my wall down. So there's x. Terrible looking x. And then I have 15 divided by 3, and I will get 5. X equals 5. Okay? Really no problem there. No big deal. So if I had another one, 5x x equals 20, I would divide, because those are multiplying together, so I'm going to undo it with multiplication, by the number that's hanging out with my variable. These are going to cancel out, so I'm just going to slash a line through them rather than draw the one like I did. And x will equal 4. Okay? These ones are pretty nice. Now, when we have the division ones, those ones get a little bit more interesting looking. They're not hard if you remember what you're doing. So let's say I have x over 3 equals 6. So what divided by 3 is going to give me 6? Okay, this is a division problem. In order to fix that, undo it, I need to multiply. So I'm going to show multiplication with parentheses. And I'm going to multiply by the reciprocal because I want to get the identity number 1. Well, there's a 1 right there, Ninja 1, he's hiding. So I'm going to multiply by the reciprocal 3 over 1 on both sides. And I know I need a 1 here as well. Now, do you see how you've got 3 times 1, 1 times 3? These all give you that identity number 1, so they go. X drops down. And now I've got 6 times 3 over 1. Okay, well, 6 times 3 is 18 over 1, and I can just really write it as 18. My point here is that if you don't see a number in front of that variable, it's 1. All right, so let's try another one of these types. What if I have this? X over 5 equals 7 over 8. Oh my goodness. Well, what we have here, my darlings, is a proportion, don't we? We do, don't we? Because we have fractions. So what would we do with that one? Well, we would cross multiply here. 8x equals 35 dividing by 8. And you're going to get x equals 4 and 3/8. Interesting. But what if we have this one, which is a little different? 2/3 x equals 12. Now, do you see how you've got this fraction here, this obnoxious little fraction, and it's stuck to the variable? They're multiplying. But you've got a fraction, a little baby division problem. So we're still going to undo it with multiplication. And again, we're going to multiply on both sides by the reciprocal. And the reciprocal here is 3 over 2. The reciprocal is the flipped over fraction. So I'm going to do that here, 3 over 2. I need to put that 12 over 1 this time. I have no choice. And when I do that, 3 times 2 over 2 times 3, they're out. X drops down, he gets released. It's because the other garbage got pushed over the wall. Now we've got 12 times 3, that would be 36, divided by 2. And we can simplify that into 18. Okay, so